This is the 7th and final video in a short series on antiderivatives and indefinite integrals, and this time we're deriving the indefinite integrals for secant and cosecant. Each of these integrals requires a similar trick, and it's worth knowing the derivation because it gives us an interesting new tool for manipulating trig integrals in general. So we'll start with the secant integral, and the key to this is a very non-obvious trick. I'm going to multiply it by secant x plus tangent x, and of course I have to divide by that as well. And the whole point of this is that when I distribute the secant into that numerator, it's going to create secant squared plus secant tangent. Notice that that's actually the derivative of the denominator, and then we're going to recognize the chain rule backwards when we see the derivative of a natural log function. So we'll go ahead and put that numerator together. It's secant squared x plus secant x tangent x. Again, secant squared, I recognize that as the derivative of the tangent function, and secant tangent I recognize as the derivative of the secant function. Now we have the derivative of the denominator sitting in the numerator, which always comes from differentiating a natural log function. So I have the natural log of the absolute value of that denominator. When you differentiate this natural log, it gives you 1 over the argument, which is what we see in this denominator, in the integrand. And then the chain rule says you have to multiply by the derivative of that argument, which we see in the numerator. Don't forget to add your plus c. And we have our new formula for the integral of the secant function. Now the cosecant integral is similar. If I naively multiply by cosecant x plus cotangent x, then when I distribute the cosecant, I get a cosecant squared, which is pretty close to the derivative of the cotangent function. And I get a cosecant cotangent, which is pretty close to the derivative of the cosecant function. But there's some adjustments to be made here. So we'll go ahead and distribute that cosecant. And I get cosecant squared x plus cosecant x cotangent x. And then in my denominator, I have cosecant x plus cotangent x. Now again, we're just trying to fit the form of what we get when we differentiate a natural log function. That's 1 over the argument multiplied by the derivative of the argument. So in my denominator, I have cosecant plus cotangent, but the derivative of cosecant is negative cosecant cotangent, and the derivative of cotangent is negative cosecant squared x. In other words, we can force the numerator to look exactly like the derivative of the denominator if we just got a minus sign on each of these terms. So what I'm going to do is distribute a -1 into the numerator. So we'll just change that plus sign to a minus. And multiplying the interior of the integral by -1 is perfectly legal as long as we compensate out in front with another minus sign. So now I have exactly the derivative of the denominator sitting in the numerator, and I get negative natural log absolute value cosecant x plus cotangent x, and we remember to put our plus c in there, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.